Hi, Mason. I'm so glad somebody showed up. I was afraid I was going to teach to an empty room today. It's nice to see you. How are you?
I'm all right. How are you?
I'm good. I'm good. I'm going to go through this as quickly as possible and then set the recording up for the rest of your class. So hopefully somebody else will join us. But if not, it's just the two of us. And I'm going to get started. So today is day 2 of our review, and we're going to talk about your key features of graphs. So that includes the x and y intercepts, your domain and range, evaluation for any given input, increasing and decreasing intervals, max and min points, and behavior asymptotes. And I just wanted to mention, in case you were wondering, most of the other teachers are following the alternative learning plan by Hampton schools, but I've decided that we've already done some of the stuff that they were going to put in the learning plan, and I didn't want to have you guys rehash it. So we're doing my own thing, and as long as I stay healthy and I don't get sick, I plan to be teaching live every Monday and Wednesdays for you guys. So in case somebody asks you and they say, why aren't you doing the learning plan, just tell them my teacher decided that we've already done some of that stuff and we're going to do our own thing. Okay? All right. So the first thing we're going to talk about is, does it pass the function test? And remember the vertical line test. If you don't touch 2 points, then it's a function. So this never touches 2 points at any given time, except for right there. That's got to go. Oh, somebody else just came. There we go. Oh, did I just throw her out? I may have. Hang on. Alyssa, hi. I see you're there. Somebody else just joined us, I think. Alyssa, I can neither see nor hear you. Let me see where your screen is. Oh, now I see you. Hi, Alyssa. It's good to see you again. So I've just started and we're doing key features of graphs, and the first thing we're talking about is the functions test. So this does pass the vertical line test. And now I'm going to go over these on this side. Not there, this one. So how about this one? Does this pass the vertical line test?
No.
No. How about this one? Does this pass the vertical line test?
No.
Yep. What about, can't I grab that? This one, does this pass?
Yes.
Yes, it does. It doesn't touch more than 1 point at any given time. How about this one?
No.
No.
No. Okay, so just remember, functions pass the vertical line test, and usually if you have a graph, it's the easiest thing in the world to check. Okay, next one, we're going to talk x and y intercepts. Remember, your x-intercepts are also called zeros, roots, or solutions. The y-intercepts are not called those. So for this graph, and you're going to see these 4 graphs come up again and again. For this graph, it looks like my x-intercept is at -2, and you always start with a -2 for x-intercept and end with a 0 for y. And then for the y-intercept, it crosses the y-axis at the +1, so we say 0 in the x spot, 1 in the y spot. And then for this one, the x-intercept here is at -3, 0, but I also have an x-intercept over here at 1, 0. And then I have a y-intercept right up here at 3, so that would be 0, 3. Now on this one, there's an x-intercept all the way from the -5 to the -2. Every single point in between is an x-intercept, so there's an infinite number of points. It's too many for me to list, so I just said an infinite number between -5 and -2. There also happens to be one at +3, so I can say 3, 0. Now for my y-intercept, it's up here at 4, so I would say 0, 4. Now on this graph, this one's a little tricky. This one has an open bubble here and a closed bubble here. So if I asked you what is the x-intercept, what would you guess? I can hear you, so if you want to say something, or type it if you're shy. What would you guess would be the x-intercept? I see you shaking your head, Mason. If that means no, there is none. There's no x-intercept. Because of this open bubble, it never touches the x-axis. Theoretically, the graph has no spot on the x-axis with a point. Now for the y-intercept, you've got 2 choices. Again, the open bubble and the closed bubble. So what would the y-intercept be?
0, 1.
0, 1 is correct. Very good. Okay. So that's X and Y intercepts. Are you guys good? Thumbs up or something in the chat room if you need help. Okay. Alyssa, your screen is turned so high up, I'm looking at the top of your ceiling. At least let me see your thumb. There it is. Okay. Okay, now we're going to talk domain and range. Remember, the domain is all of the x-axis variables that have a point. So every number on the x-axis has a point because this graph goes forever to the left and forever to the right. So I'm showing it like this. It goes forever left and right. So your domain is all reals. And another way you can say all reals is negative infinity to positive infinity. Do you guys remember we did this?
Yeah.
And then the range also goes forever to the bottom and forever to the top, or all the way negative and all the way positive. So we would also say that the range is all reals. Now in this graph, it's kind of the same thing. The domain goes forever left, and it goes forever right, and it goes forever down and forever up. So we would again say all reals for domain and range. And I just want to remind you that when we did domains and ranges, we did brackets and parentheses. Parentheses are when you can't reach that value, like you can never actually reach negative infinity or infinity. Or if this were an open bubble, right, say here, and then it went down, then we would say you can't reach that either, so it would be a parenthesis. But if you actually have a point there, a value at that point, you put a bracket, and I'll show you on the next slide what I mean. So for this one, notice there's no arrows. It starts at -5, and it goes forever this way. All these are x values. But then I end right here at +1. So what I have to do for my domain is say bracket -5 bracket +1, because I actually have a point there. So if I actually have a point, I stop and say bracket, and I have a point here, I stop and I say bracket. Now when I pick up at 2, notice that there is no actual point there. So this is where you put a parenthesis. And then it goes from 2 all the way over to 5, and it does have a point at 5 because it's a solid bubble, so I put a bracket there. So for my second part of my domain, I would have 2 with a parenthesis, 5 with a bracket. And then this U in between the two means take these points and the union of these points, and that's your total domain. Do you remember U stands for union? We didn't really teach that, but I've seen it a couple times on tests, so it's worth talking about right now. The union means add this to get your full answer. It's a piece of this and a piece of this. For the range, our low value starts down here, and again, it's got a bracket, so I would start at -2, and then it goes up here, but this point is overlapped by this piece of the graph, so the range actually continues to go up till it gets to 4. And so you should have a bracket from -2 to 4, because even though this is an open bubble, there's a closed point on this side of the graph. So it does actually include the number 1. And then here, again, we're going to go infinitely down. And well, let's talk about the domain. The domain goes forever this way and forever this way. And since there's a point here, you can say it's all reals. Now the range starts from -infinity and crawls up the graph until I get to 0, but I don't include 0, so I'm going to have to say parentheses at the 0. There's no actual point at 0. But then it picks it up again at 1, and so there's going to be a bracket here at the 1. There was a parentheses at the 0, and it goes up forever to +infinity. So it goes from 1 with a bracket to +infinity. We never put brackets on infinities. And again, we say union because we're saying this piece and this piece together make my range. Is that good?
Yes.
Alyssa, you good? Alyssa? I can't see you.
Yeah, I'm good.
Okay. I can always go back over it if you need me to. Okay, so now when we say evaluate a function for a given value of x, we're just saying what is f of x. So what is f of -3? So if I'm looking at this graph, and you've seen this one already a couple times, I find -3 on the x-axis, because that's what the x value would be. It would be f of x. And I read the graph at that point. Well, the graph has a point right down here, and it's y value 1. So f of -3 is -1. I found -3 on the x-axis, went to the graph for that point, and read the y value. So f of -2 So if I'm on the x-axis at -2, there's a point right there on the axis, so my y value is 0. F of 0, I go to 0 on the x-axis, find the graph for that place, and I get a y value of 1. F of 1 is 1, and f of 2 is 4. You guys feel comfortable with that?
Yes.
Okay, Mason, do the next one for me. This is your graph. Okay, so what is f of -3 on your graph, Mason?
0.
0. What is f of -1?
2.
What is f of 0?
3.
And what is f of 1? Be careful, there's a trick here.
0.
0, good. All right, Alyssa, I'm going to have you do this one. You've got a few to do. So what is f of -5?
0.
How about -2?
0.
And all those points in between. How about f of -1?
3.
What about f of 0?
4.
Good. F of 1,
3.
3, and f of 2.
1.
What do you think is going to happen when there's an open bubble?
It doesn't count.
It doesn't count. And another way,
Also,
go on.
I don't know.
I think you were about to say it. It's undefined there, right? Because it doesn't count. So there won't be a 1. So then f of -1 on this graph looks like a -1. It's hard to read it, but I think it is. F of 0, okay, I have two choices, here or here. So obviously I want to take the solid bubble, so it's 1. F of 1 looks like 2, and f of 2 looks like 4. Okay, are we good on the evaluates?
Yes.
Good. Okay, now intervals of increase and decrease. So I broke these 4 graphs into their pieces, the blue, the red, and the green piece. So for the blue piece, it actually travels from -infinity all the way to -1, and then it stops. And if you read the graph from the left side to the right side, like you would read a book, it looks like the graph is rising. So I would call that increasing. Then the red piece goes from an x value of -1 to +1. And that's just flat, it's horizontal. So we call that constant. You don't increase, you don't decrease. It doesn't rise, it doesn't fall. And then the green piece from 1 to infinity, again, is rising. So I would call that increasing. So those were the 3 intervals for this first graph. Notice when I say intervals, I'm reading x values only. I don't care what the y-axis says. Intervals of increase and decrease are all about the numbers on the horizontal axis only, because we're reading it horizontally. Got it? Okay, so let's see. Alyssa, you're going to do this one. What is happening from -infinity to +1 on this graph? I'm going to reset it by pulling these back. Where should I put the -infinity to 1? Under increasing, decreasing, or constant? What does your graph do as you go from the left to the right for this piece right here?
Increasing.
Good. The blue piece that goes from 1 to infinity on the x-axis, what is it doing here?
Increasing.
Good. Yeah. So your graph has all increasing intervals. All right, Mason, I'm going to give you this graph. So there's 4 pieces actually. So for the negative piece, it goes from -5 to -2. Notice there's no arrowhead, so it starts at -5 and it ends at -2. What should I call that part?
Constant.
Constant. And then this blue piece goes from -2. So what is it doing from -2 to 0? Just for this piece right here.
Increasing.
It is increasing. And then this piece goes from 0 to 1. So what is that doing?
Decreasing.
Decreasing. And then this piece goes from 2 to 5. That should be a bracket. 2 to 5. What is it doing?
Decreasing.
Say it again.
Decreasing.
Decreasing?
Yes.
Okay. Good. And then I'm going to do this last graph. So the red part is from negative infinity to 0, and it is actually going up. And the blue part is from 0 to positive infinity. Both of those are going up. Okay. You guys good on increasing and decreasing?
Yes.
Yes.
Okay. Max and mins are just, they're the high points and the low points. Remember I called them hills and valleys? So the hill has a maximum right at the tippy top, and you would read its y value, and I'm not sure exactly what that is because it's right in between, but it's somewhere between 0 and 1. And then it has a min where the valley is down here, and its y value is a little bit less than -2. So if I move this graph off and I focus on the graph below, where do you suppose a max is on this graph?
4.
4, good. You're reading the y value. I love that you read the 4. And where's the min?
-2.
-2, very good. So maxes and mins are just the highest point in a localized area and the lowest point in a localized area. And in this case, the highest point on the whole graph is 4 and the lowest point on the whole graph is -2. Always read the y values. Okay, end behavior. This one we might need to go over a little bit more, but remember end behavior. First of all, this sideways arrow is read as approaches. So we say as f of x, or the y value, because f of x means y, approaches negative infinity on the left side of the graph. It's going down. And on the right side of the graph, f of x or y is approaching positive infinity because it's going up. Remember when we taught it, I taught you to say down, up. Always tell me the left side first and the right side next. So this would be down, up, this would be up, up, and this would be, this was neither up or down, but this side would be up. We'll talk about that in a minute. So for this graph, the end behavior is f of x, or the y, is approaching positive infinity as x goes negative, and positive infinity as x goes positive. So on both sides of the graph, the negative infinity and the positive infinity for the x values, the y's are both going to positive infinity, and they call it f of x. So far, so good?
Yes.
Okay. Now this end behavior, I can easily see that f of x or y is going to positive infinity as x goes positive. So as x goes positive, f of x is going positive. But on this side of the graph, as x goes negative, notice how the y levels off because there's an asymptote right here. So the y doesn't approach positive or negative infinity. It approaches the x-axis, or it approaches 0. I just lost her. Okay. So are you good on end behavior?
Yes.
Okay, I have one more graph for end behavior. What's happening on the right side of the graph as x goes to positive infinity? Where's y going?
It's increasing.
Okay, so what would you call that,
Oh,
positive or negative?
Positive infinity.
Positive infinity. Now, what's happening on the right side of the graph? As x goes to negative infinity, how's y doing?
It's leveling off.
It's leveling off at what y value? That's the key.
4.
4. Very good. Okay, so that's end behavior. And then the last thing I have for you is asymptotes. So remember, asymptotes are lines that we could draw through the graph and never touch any parts of the graph. So if you look, they've put purple dashed lines through this graph here, here, and here. And all of those purple lines are asymptotes because the graph is approaching it, but it's never going to touch it or cross it. It's going to just keep going up and stay close to it. There she is. We lost you for a moment, Alyssa. I'm glad you're back. I don't know what happened. Somebody else just came in, I think. Nope, that was you. Are you back with us, Alyssa?
Yes.
Okay, good. We were missing you. Okay. All right, so what do you think, Mason, are the asymptotes on this graph? And you actually have to count your tick marks because they didn't label your axis.
Okay.
And you also have to say x equals or y equals because some are horizontal and some are vertical.
Y equals 2 for the top one.
Good,
X equals -5 for the left one.
excellent,
And x equals 5 for the other one.
perfect. You did great. Okay, Alyssa, you kind of came in late. So do you know how to do asymptotes? You just read the x values and read the y values of the dashed lines. You want to try yours? Does that make sense?
No, can you explain it one more time?
Yep, I'll go back and show you the slide that we missed. Okay, so there's an asymptote on this graph at y equals 4 because the graph is leveling off and approaching that y value, but it's never going to touch it or cross it. And there was an asymptote on a previous graph here at y equals 0. So wherever you see a dashed line, that's an asymptote. So this line is at y equals 0, and this line is at y equals 4. And Mason had lines that went at x equals -5. He counted 1, 2, 3, 4, 5 back and 5 front, and x equals +5, and at y equals 2. So where are your x asymptotes? Where do you think your graph has asymptotes that it approaches but never touches?
3
3 for sure.
and 1.5.
1.5 or 3/2. And then how about your y-axis? Do you see there's one here?
0.
0. Perfect. That's your asymptotes right there. Well done. We're done. That's everything. So let me show you where you go for your homework. You've got a formative again. You've got your quizzes code is in your Google Classroom, and I'm trying to get everybody to submit everything for the week by the end of that week so that I can kind of keep up with all my assignments. So let me show you what formative looks like. If you go to your formative, you're going to have, it's going to be different this time. It's not just multiple choice. You're going to have some that make you match. So see this little, looks like a spinner reel. If you grab it, you can drag it to the correct match with it. So this side is the function and this side is the domains, and you have to pick which one is right by dragging it to. And then here's a range multiple choice, matching. So you have to drag your picture to the correct range. And then this one is a sorting one. It's kind of interesting. It's a matching. So what I'm saying is these graphs either have a domain or a range that have all reals. So if you think, for instance, this domain is all reals because it goes forever this way, you drag it to the domain of all reals and you just let it in there, okay? And if you don't want it there, you just click it off. And if you think it has a range of all reals, you drag it to the range box, okay? And then for these, they want you to list the x and y intercepts. Remember to make it an ordered pair because the way it checks to see if you're right, everything has to be just right. So you need the parentheses, you need the x value, comma, y value. So make sure when you type in your ordered pair, like for instance, this point would be, it's a -1. So you would say parentheses, -1, comma, 0, close parentheses. And then you tell it what the other x value is. There's 2. And then you would give the y-intercept. Same thing here. Here's another matching where they ask you, okay, take the graph on the left and match it with the part on the right that's true about that graph. Like, does this graph increase from -1 to infinity? So if it increases from -1 to infinity, then you would drag this to match that, okay? And then this one says evaluate for d of -1. So here's -1. What is d of -1 equal? And remember, you're reading the y value, so that's a multiple choice. You just click the right box. And then this one is the same, this one is the same, this one is the same, this one is the same. And then this one is another one of those sorts. So you have maxes and mins, and you know these points are either a max or a min. So you drag the point to whether it's a max box or whether it's a min box. And you just let it go in one of these. And then if you don't want it there, you click it off. And then these are the last two are asymptote questions. So you have to select all that apply. If you just get one, then you won't get it right. So select every one of the asymptotes. And that's it. So that's your formative. There's another link that I put in your Google Classroom that I really, really like. So if you go to this key features of graphs, there's a function features practice and it looks like this. And I think this is fantastic. It actually asks for all of the things that we've gone over. It asks you for y-intercepts, x-intercepts, intervals of increasing and decreasing, relative maxes and mins. It's pretty interesting. So if you have a chance, there's no way I can grade it because there's no way for you to submit this. I looked for it and I didn't see anything. So, but if you have a chance, do the function features because I think it's really cool. And I've already posted the notes for today. I'm just going to go ahead and close the video up and then post that as well. So you'll have everything you need for today right there. Do you guys have any questions about the homework for tonight or for last time's homework?
No.
You good? If you're good, I'm good. So we're done. All right. Remember, I'll see you guys Mondays and Wednesdays of every day at this time. So I won't see you again until Monday, but you can always email me if you have a question. Okay. All right.
Okay.
You guys take care. I'll see you later.
Thank you, you too.
Bye-bye.